Question 5, Part D. A total of 300 tickets are sold in a raffle which has 3 prizes. There are 100 red, 100 green, and 100 blue tickets. At the drawing of the raffle, winning tickets are not replaced before the next draw. Part 1. What is the probability that each of the 3 winning tickets is red? This is a probability experiment with selection without replacement. So as we remove a red ticket, we're depleting the number of red tickets by 1, but we're also depleting the total number of tickets by 1 as well. Now, the denominator of each of these fractions represents the number of tickets in the barrel at that particular draw. So the probability of drawing 3 red tickets is 100 over 300. This is the probability of drawing a red ticket on the first draw multiplied by the probability of drawing a red ticket on the second draw. Notice that we now have 99 red tickets in the barrel out of a total of 299 tickets, since we've already drawn 1 ticket out of the barrel here. And then we multiply that by 98 over 208, so there's 98 red tickets left to choose from out of a total number of 298 tickets in the third draw. Multiplying all 3 of these probabilities together, we get 1,617 over 44,551, which is approximately 3.63% chance. Part 2. What is the probability that at least one of the winning tickets is not red? The complement or opposite of drawing at least one ticket that is not red is drawing all 3 tickets that are red. Hence, the probability of drawing at least one ticket that is not red is equal to 1 minus the probability of drawing all 3 tickets that are red. Now, from part 1, we found the probability of drawing all 3 tickets that are red, and that's 1,617 over 44,551. Hence, the probability of at least one ticket not red is equal to 1 minus 1,617 over 44,551, which equals 42,934 over 44,551, which is approximately 96.37%. Part 3. What is the probability that there is one winning ticket of each colour? Let's consider a particular case, the probability of choosing red, then green, and then blue. So the probability of choosing a red ticket on the first draw is 100 over 300. So a ticket is taken out of the barrel, a red ticket. That still leaves 100 green tickets and 100 blue tickets left and 99 red tickets. So there are 299 tickets left in the barrel, of which 100 of those are green. So the probability of choosing a green ticket on the second draw is 100 over 299. And the probability of choosing a blue ticket on the third draw is 100 over 298. Since we have 100 of each colour and we're interested in the probability of choosing 3 different colours. However, there are multiple ways of choosing the colours, so we need to take into account the order in which the colours are chosen. So that particular case that we just looked at, we chose red first, but we could equally choose green first or blue first. So the number of ways of choosing the first colour is 3. Once we've chosen a colour in the first draw, that leaves 2 left to pick from. So let's say if we've chosen red first, that means we could choose green or blue in the second draw. And in the third draw, whichever 2 colours are chosen, that leaves 1 colour left to choose from. So the total number of ways that we can get red, green, blue is 3 times 2 times 1, which is 6. So to get the probability of 3 different colours, taking into account the order in which they're chosen, is 100 over 300 times 100 over 299 times 100 over 298 times 6, which equals 10,000 over 44,551, which is approximately 22.44%.